Hey everyone, it's Berm, and this is Level 0 Networking. In the last video, we did multi-tenant utilizing MPLS, which allows us to talk between 100 different customers without having to do a tunnel per VRF. This can be very useful, but may not be necessary depending on the size of your environment. That doesn't immediately mean that a use case of MPLS design can't still provide value. Let's give a warm welcome to Microsegmentation. This design will use a basic topology with a single hub and two spokes. The hub won't serve any traffic at a hub site. It'll strictly be serving as a route server. This will put all customer traffic on the spokes. Site 2 will also host a secure internet connection. Why would we want to utilize the internet at another site if every site has its own internet? I'm glad you asked. When you have a large number of sites, you may want to limit the amount of paths to the internet you'd like to secure. By routing internet out of a smaller number of sites, you can more easily maintain a sound security posture. Again, we will be using the 1.4.0 RC3 image. The link to the image is in the description below. This time, instead of separating customers with VRFs, we're going to be separating services. Here's a quick glance at the VRFs being used in this lab. Some of this configuration already exists from the last video. If you need more information about it, be sure to check that one out. I'm going to go ahead and link that in the description as well. First, we'll be configuring the VRFs. This configuration is going to be very similar to the last video. We'll be enabling the VRF import and export, and then importing and exporting based on the table ID assigned. These configurations will be for both spokes. Let's go ahead and configure spoke 1. Now we'll go to spoke 2. The VRF configuration is going to be exactly the same as it was on spoke 1. Now we'll configure the interfaces. Spoke 1 is going to be 10.11 and spoke 2 will be 10.12. As you can see, we did 10.11 for spoke 1, so it's going to be 10.11.1, .2, .3, and .4. Now we'll do the same for spoke 2. The key difference between spoke 1 and spoke 2 is going to be Ethernet 2 on spoke 2, because that's going to be the internet connection, or the iNet VRF. For the multi-point BGP config, we're going to have 2 listener addresses. We'll have one for the VP and v4 peers and another for the ZeroTier addresses. We're going to go ahead and configure those on the hub now. An important thing to remember here is that you do need to turn on the MPLS interface inside BGP, but then also inside of MPLS. Now we'll go ahead and configure BGP on the spokes, on spoke 1, and now on spoke 2. The dummy interface that's being used for the update source has already been configured ahead of time. Now we'll move on to the internet firewall portion of the config. We're going to set up BGP between spoke 2 and the internet firewall and then advertise the quad 0 to spoke 2. We'll put that in now on spoke 2. Now we'll go ahead and configure the internet firewall as well. As you can see, we're adding a NAT source rule. That's for sending the traffic out to the internet. And then we're also setting up the BGP to spoke 2. All right, now I'm going to go ahead and commit everything. This should commit on every device. And it is. The BGP router ID is just a warning. It's going to utilize defaults if you don't put something in there manually. Now let's make sure that we have the routes. Run show IP BGP VRF all. As you can see on spoke 1, we do have the 10.12 network on here as well. Since BGP looks good, let's do some quick pings to make sure our label switched paths are good as well. So far, it looks like all the VRFs are working. And finally, we'll test the internet from spoke 2. As you can see, everything's working. The last test we want to do is make sure that we cannot ping between VRFs. So this ping should fail. There we are. We cannot ping between the VRFs. We can only ping between the spokes on the same VRF. All right, everything looks good. In this lab, we're going to be very broad with the VRFs. For an actual deployment, you may want smaller blocks within the VRFs. For instance, inside the server's VRF, you may want Active Directory, SNMP, DNS, or DHCP. Here's our current plan for the VRFs. Now, let's enable route leaking. This part is very easy. All we need to do is import additional route targets into the VRFs. Also, a quick side note, there's currently a bug in RC1 which prevents additional imports from working if you use route target both. And when typing route target import, it will override any existing import statement. Make sure you account for that when adding additional route targets. Now, let's get into the config. We'll be importing into each VRF based on the VRF info. We'll go ahead and add the new import statements to Spoke 1 first. As you can see, we're changing the import statements for the iNet, users, admin, servers, and management. And this is going to allow us to talk between the VRFs. Now we'll go do the same thing for Spoke 2. As you can see, this is the exact same config that we put on Spoke 1. We'll go ahead and commit and save. Now let's check the BGP route table for each VRF. We're going to run this command on Spoke 1. As you can see, each VRF now has multiple routes inside of it. And finally, we'll go ahead and run some more ping tests. Users are able to get to the internet utilizing Spoke 2. Next, we'll go from users to users. Per our design, this shouldn't work. Users should be able to talk to admins and servers, which they can. And finally, they should not be able to talk to management. All right, everything is working as expected. Users can access the internet, admin, and servers, but they cannot reach other users or management. We have bonus material. We have created a script that will allow you to manage the import of your devices using a GUI. To do this, you're going to enter the shell by using sudo su. Now, we'll navigate to the config scripts folder. Next, you will want to clone the repo for the script. I'll have the link in the description. Then we're going to download getpip.py. This link will also be in the description. Next, we'll install getpip using the break system packages switch. Then we'll install Flask also using the break system packages switch. Now, let's go back into the configuration mode of VyOS. From here, we're going to want to set the API key that we want to use. I'm going to use the word key since this is just a lab. In a production environment, you would want to use a real key. The value you want to change is going to be key in quotes. Now, if you are going to change the key here, then you'll need to update the script. To do that, you want to update the key string inside of the script. That file can be found in config scripts VyOS_easy_microsegmentation. You're also going to need to sudo this. The API key is going to be right here. You just change this key to whatever you set when you ran the command. To save it after you've edited it, you're going to hit Control-O. And then to get out of the file, you hit Control-X. After this is complete, you're going to want to commit and save. All right, let's go over to the browser and check out what it looks like. As you can see, we have all of our VRFs that we created earlier, and we can choose if we want to have import turned on or off. It's as simple as just clicking the button. Now this will allow the admins and the users to talk, iNet and the users to talk. All we have to do is push config to VyOS. Back over here, you can see that the changes are being made. And right here, we have config pushed to VyOS successfully. Well, that's it for this video. Thanks for stopping by. If you enjoy the content, make sure you like and subscribe for more. Also, if you have anything you'd like to see, feel free to let us know in the comments.